This video is an overview of our first remote woodturning demonstration. We've presented demonstrations about eccentric wood-turn jewelry many times to nearby clubs and at the AAW Symposium in Tampa. As with most demonstrators, it's typically impractical for us to demonstrate much outside of a few hours' drive from our home. The First State Woodturners Club in Delaware meets at a woodcraft store. They invited us to do a demonstration for them remotely from our home in New Jersey. This video is an attempt to speak to other woodturners, introducing the viability of remote demonstrations, so they can see the type of high-definition video quality that's possible with minimal equipment, and how it can be an effective way of sharing their knowledge and experience. Hopefully this will encourage more woodturners to offer remote demonstrations, where the turner stays in his or her own shop without having to deal with all the logistics and the expense of travel. Similarly, this could encourage woodturning clubs to invite turners to demonstrate at venues where it would otherwise be impractical, impossible, or unaffordable. Remote demonstrations, if done well, can benefit the demonstrator and the audience and make learning about woodturning global, removing geographic limitations. At the club venue, they had a computer, a large TV screen, a wireless microphone, a webcam, and a good internet connection. Although not shown in this video, we were able to see and hear the club members, answering questions as they arose, so it was quite interactive. The feedback about the presentation was very positive. Now for a little bit about the setup. This is a basic overview. I'll go into more detail at a later time in subsequent videos. A basic setup would have one demonstrator with 3 cameras. However, this proof of concept session was more than a basic demo. It was a good test of pushing some of the limits. We were 2 demonstrators, but not in the same place. I was in our basement using 2 rooms of our shop. Lauren was 2 floors above me at her workstation. We each had a notebook computer with video switcher software, so we controlled our own cameras. I decided which camera inputs would be sent out to the audience. I had 3 USB cameras, one above the lathe with autofocus turned off. One was on a microphone stand with a gooseneck, so the camera was easily repositioned. The autofocus was turned on. The third was pointed at me, and just to be a little higher tech about it, I had a green screen behind me so I could simply put myself into any other video, either as picture-in-picture or full size. All of the cameras are on quick-release plates so they can be easily moved among any of the mounts. Similarly, Lauren had her 3 cameras, one pointed at her, one mounted on her workstation for fixed focus of close-ups of the piece she was working on, and a third on a microphone stand. This was also a test of the audio quality possible under rather noisy conditions. I was using a wireless microphone with excellent noise suppression. This was important because I wanted to demonstrate using the actual tools and procedures I use when I turn. So I had to be sure that the audience could hear me clearly while I wore my respirator helmet and while the very loud dust collector was running. It's possible to add recorded videos, photos, PowerPoint slides, title slides, and many other types of inputs, then mix and match them for the audience. One thing to note, this was our first and proof of concept demonstration. The lagging that you'll see on Lauren's video feed and the color of one of my cameras has been corrected in more recent demos and is no longer a factor. So here are some clips recorded during the demonstration with notes about what's being discussed and the cameras being used. I hope you find it useful. When we do even an in-person demo at a club, because the things that we're working on are usually about 2 inches in diameter, you can't just come up and everybody's sitting in the pews there. They can't see what's going on unless they're looking at a TV monitor. So the thought is, well, as long as you're watching a monitor, we don't have to be there. We don't have to drag all of our equipment down, set it all up at your venue, do the presentation, and then bring it back and then reassemble the shop. So this is Lauren. Lauren,
Hi.
say hello.
Hi, everybody.
So Lauren has also 3 cameras. She's got one that's going to be pointed in her workstation, which is where she's going to be doing some drawing. She's going to be doing archival ink work on a pendant. And then she also has a movable camera, and the one that you're looking at right now is just the one that's in the lid of her laptop computer. So this is a piece of Paduke, and it's got red and blue jasper in the center. And then Lauren, once you have something that's a wood turning, well, how do you turn it into a piece of jewelry? What do you do to make it into a necklace? By being able to overlay the shape of the egg that she wanted, and she basically just took a cell phone and photographed a chicken egg from our refrigerator and overlay it on the spindle. She was able to turn to that shape. So that's kind of a cool technique.
And to the size that I wanted.
So now she's also applying this same type of ink work to things like shaving brushes. And you can see, we've got lots of different brushes, and this was something we put up from our Etsy store. There's a couple of things that we're going to be doing here, and I wanted to show you a couple of different tools that you may or may not be that familiar with. We're going to be working with this thing called a pendant backer plate, or an eccentric turning plate. Important when you do this, and you don't have to use a mandrel. You could just use a 3/16 a piece of all thread or whatever in a chuck, but I like using a mandrel. And in particular, this mandrel is drilled in the back for a drawbar, and I made drawbars for each of my lathes and for every lathe that I demo on. And it's nothing more than a piece of all thread rod with a handle on it and a washer. The all thread goes through the headstock. The mandrel goes into the taper, and then you tighten it down, and that keeps the mandrel from working out of the taper. After all the turning is done, I'm going to show you this other rig here. This is a Dremel motor tool. This happens to be a cordless version on a Dremel drill stand, drill press. And what it will do is, this is going to be the way that I'm going to drill a little hole in the edge of the pendant to accept a screw eye or to accept a pin. And this is a circle template. You can get it at any office supply store. And what I would do is say, if I want 2-inch circles, I will basically just go like that and move to the next one and go like that. This, by the way, was a piece of maple that I got from Lowe's. So what I'm doing here is I'm using this tape. It's called Spectra tape. You can get it at Woodcraft.
Yay!
You can buy them out while you're there. And what's interesting about this tape is it's cloth backed and it is pressure activated. So I'm just going to cut a little piece of it here. Basically, just put it on here. And what's nice about it is you're not fighting the tape. So I'm making a little slice here, and it makes it very easy to remove the release paper. I'm going to bring in the tailstock here and put this little jam plate on it, and that way I can basically center it on the jam plate, press it up against the wood, sort of center it. It's not critical in this case, but now it's in place and I've tightened it down. It's activating the glue. I don't turn on anything until I've got my respirator helmet on. This one happens to be a VersaFlow that I actually have attached to a long hose going to a HEPA room filter. So some of my other ones are Breathe Easies or Airstreams and such. We've got a few of those, but I happen to like this. I don't mind being tethered. What I do here is I'm turning on the lathe. Always a good idea to spin it around a little bit. And I'm running at about 1,000 RPM. And what I'm going to try to do here, in general, just for the turning, is I'm not going to be pushing in this way. I'm going to be pulling this way, because basically, wherever possible, I want to be able to turn towards the tape, not slide it across the tape. So if anything, I'm adding additional pressure to the tape. So you'll see that it's now spinning around the center. Now you see one of the reasons why I really want that drawbar in there. So this is the arc that I want to draw, about that. Okay? And so when I do this, I'm going to turn this down to 250 RPM. I'm going to make sure that it can spin. I'm going to make sure everything is tight. And I'm going to go in and just kind of scrape out that arc. So you can see why the flat tool rest is a really handy thing here. And you can see how it scribed the arc and how the arc is thicker here and thinner on the end. See where I'm getting the bevel on the inside to match the, or to try to intersect with the convex that I turned on the outside. And so I'm really just kind of sweeping it around. And this is where sandpaper comes in. Because right now I've got one edge here and another edge here, and this is where, when you come in like this with some sandpaper, now you can just go and ease it around and blend the two surfaces very nicely. And you can see that this surface and that surface are starting to come together, and I would just do it a little bit. I would do it a little bit more and go through the grits. But what's nice about them is when you start working with them, they get into all the little crevices and they're very gentle. And since I like to go through the grits rather than me remounting it all the time from one going through the different grits, I decided to put them all on one arbor. This is Lauren's lathe. I go the other side, 1, 2, 3, 4, 120, 180, 220, 320.
Findings are just things like the clasps and how do you close the necklace. The easiest thing to do is to get a prepackaged necklace that's got the finding on it. They have them all over the place. If you don't want to get into that, I like making my own findings. This one I had made by wrapping wire. There are a ton of beads. You can make your own beads on the lathe as well. Beads and coves. There's glass beads and metal beads and just about any kind of bead. I've made them out of polymer clay. This is a polymer clay bead. And connecting them, you use chain or wire.
This little beading tool. And beading tools have two different kinds of beading tools. There's some that are used where the bead runs down the flute, and this one's a little unusual. This one actually gets used like this, not like that. So what I'm going to do here is just bring it in slowly, and I rock it back and forth a little bit. And so what we've done is we've cut a groove, a bead in the workpiece. And that's all well and good if you want just a little bead. But I want a raised bead. And so there's a wonderful line that says the way you make a statue of an elephant is to start with a big block of marble and chip away everything that doesn't look like an elephant. So in this case, what I'm going to do is I'm going to use square carbide bit. And again, I could do this with a spindle gouge, and I may actually switch to a spindle gouge. But basically what I'm going to do is now try to take material down and just have the edge of that corner come up to the bead. So you'll see that what I'm doing is I'm just coming up closer to the bead so that the bead starts to stand proud of the material that I'm removing. And I would do this on both sides. So I would do this until I get to the base of the bead, and then on the other side, going to again try to make a domed section. I want kind of a convex section here. But you see
how the bead is now emerging.
By the end of the 90-minute session, Lauren had almost finished the face of the pendant. After the demo, she worked on the back of the pendant and added a chain. We sent the finished pendant to the club with our thanks for inviting us to demonstrate.